Times 2. Okay, what's A for?
Amplitude.
Amplitude, okay. And what does B tell us? The number of
Waves.
wavelengths
Wavelengths.
within.
2 pi. Yes.
Okay. And if we're using degrees, it would be
360.
360 degrees. Okay. What does C tell us?
One was vertical, the other one was horizontal.
Good.
Oh, that one's vertical. Horizontal. Yeah.
This is the horizontal shift. Horizontal shift. Okay. And that applies when the brackets go there. Okay, so C must be inside the brackets. Now, different textbooks, different authors, they like to put the brackets around here. Okay? And if you ever see that, then the horizontal shift is no longer C. The horizontal shift is actually now C divided by B. Okay, can you see that? So what's the coefficient of x here? It's b, all right? But if we remove the bracket and put it there, okay, the coefficient of x is 1 inside the bracket, so now the vertical shift is c. Okay? So when it comes to shifting horizontally, it's always easier to use this form. Okay? And then we've got D, which, Levi, is the vertical shift. Good. Alright. So we have our x-axis. Are we in radians or degrees, do you think?
Degrees.
We're in degrees, most likely. I mean, we could technically have 180 radians and 360 radians. That's still a possibility. But let's work in degrees. And so if we were to draw the sine x curve, where would it be? We'd start here, go through there and there, and my maximum is here at how many degrees?
90.
90, right? 1/4 along the way to 360, and -1 will be at 270 degrees. Okay, so that's our sine curve. Let's type it in and verify that. Ha!
You close the thing, if you open the thing back up again, it will push it back over.
Oh, okay.
From there.
There it is. Very good. Okay. So, let's see now. If we change the value of A to be 2, what happens?
It will go up to 2.
It'll
on
go
the
up to 2.
y-axis.
Okay, so that's going to go to there. What happens here? What happens to that coordinate?
Nothing.
Nothing. That's true. It stays the same. Very good. And this coordinate will go down to 2. Good. And this coordinate will remain the same. Okay, so let's put that 2 in and verify that that's true. And that is true. Okay, now let's say that I want a graph. Let's say I want a sine graph that starts here, goes to there, and goes through here and here. What would the equation be?
We would have to change the vertical shift.
We would have to change the vertical shift.
Would it
That's
be
true.
4 sine?
Change the vertical shift to 2. So what letter are we talking about?
D.
D. That's
D
right.
plus 2.
So that's now 2.
We'll also have
What
to
else?
change that amplitude to 2.
Okay, so the amplitude is going from 2 all the way to 6.
4.
What's
4.
that amplitude? It's 4, isn't it? Do we have a horizontal shift?
No.
No, we don't. So C will be,
Just nothing.
it'll be 0. And the number of wavelengths within 2 pi
1.
is still 1, isn't it? So the B value will be?
No.
Will be 1. That's right. Okay, so essentially this graph is y is equal to 4 sine x plus 2. Okay, so let's type that in. 4 sine x plus 2. And did we do it? Yes, we did. There we go. Not too hard. Now, let's say that we want to shift the same graph to the right, and we want to shift it there, 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 and there. On the grid, it's 2 squares to the right.
Yeah. So,
Alpha pi.
yeah, 2 squares is 90 degrees.
Okay, so 2 squares is 90 degrees. And are we shifting to the right or to the left?
Right.
To the right.
So it'll be
So,
negative.
which value are we changing? A, B, C, or D?
C.
We're changing the C value.
It's got to be negative because it goes to the right.
Okay, it has to be a negative if we're shifting to the right. And how much did we say?
It was 90.
90.
90.
Alright, let's see if that's the case. So over here, this is now x, sorry, yeah, actually I can do that. X take away 90 plus 2. Let's type it in. Take away 90 equals, did it work? Yes, it did. Okay, good. So I'm ready to give you a harder question now. Mix them all up in together.